Welcome to part 2 of the module on framework examples. In the previous part in this module, we presented scope, commonality, and variability analysis as a method for developing and applying software product lines and frameworks, and we also presented a couple of examples of applying scope, commonality, and variability analysis to Android and ACE. We're now going to dig a little bit deeper and discuss some examples of Android framework components. And naturally, we'll be emphasizing the commonality and variability of these components and frameworks as we go through this part of the module. The two framework components we're going to focus on here are activities, which provide a visual interface for user interaction in Android, and services, which are classes and objects and components that run in the background and perform long-running operations or allow access to remote resources. So here's a quick recap of the Android activity. We've talked about this before, but here's a little summary. As we mentioned, an activity provides a visual interface to user interaction. An activity typically supports one thing a user can do. So it might allow you to view an email message or send an email message. It might show a login screen. It might allow you to download files from some remote server. Applications can include one or more activities, and there are various ways to figure out what activities are available by looking at various tools you have in the Android development environment for Eclipse, for example. If you take a look at this URL, you can find out lots more information about activities. Implementing an activity is fairly straightforward. You inherit from the activity class, and you override a number of so-called lifecycle hook methods. And then we are going to include that activity with the appropriate metadata in something called the Android manifest.xml file, which is basically a file that describes properties and metadata and information, resources about how your activity and other activities and other parts of Android, like services and so on, get packaged together and downloaded. Android communicates the changes that are taking place to the activity via its hook methods and its lifecycle hook methods as the states change. We'll talk a lot about this in a second, and I'll walk you through the various states. But before we do that, just a quick note as we go through this discussion to keep in mind the commonality and variability of what we're talking about. The activity class provides a common interface for interacting with users, including operations that are performed as you move between lifecycle states. And of course, the variabilities are provided by enabling subclasses to override various methods, especially the lifecycle methods, to do the necessary things to remedy and address what happens as the states change in the system. Let's first talk a little bit about the activity lifecycle states. This discussion isn't really specific to concurrent and network software, but it's very relevant to frameworks because it gives an illustration of things like inversion of control and commonality and variability. When an activity starts up, when it's initially launched, there's a set of initialization steps that take place as callbacks to these hook methods. On create, on start, on resume, which we'll talk about. Once the activity is initialized and up and running, then various things can happen. It can be visible and have the focus so the user can interact with it, touch buttons, enter information into text fields. You can also do various things that will cause the activity to be paused or stopped. Things can be paused when the activity doesn't have focus but still visible. For example, if a dialogue or a toast pops up. And when an activity is replaced by another activity, it becomes stopped. And at some point along the way, an activity will either decide to terminate itself voluntarily, or the Android runtime system may shut it down involuntarily because it's perhaps running low on memory, or it's decided the activity hasn't responded in a while and maybe hung. So in that case, there's some other things that take place. Take a look at this URL for more information about how these different lifecycle states occur in Android. So getting back to the concept of frameworks, Android defines a whole set of lifecycle hook methods that you can fill in your activity subclasses. And we're just going to talk about them very briefly here. The onCreate method is called to initialize an activity when it's first created. The onStart method is called when an activity is becoming visible to a user. The onResume method is called back when the user returns to an activity from another activity that was blocking it on the task stack. OnPaused is called when a user leaves an activity that's still visible in the background. OnStop is called when a user leaves an activity for another, such as launching a picker to choose a particular contact from your address book. And OnDestroy is finally called when things are going away and the system has decided to shut you down, or the activity has decided to shut itself down. There's more discussion about these various callback hooks here. Here's a very simple, quick example to illustrate a useful helper class to keep track of when and how these various callback hook methods are invoked by the Android runtime environment. What you do here is you define a class called Lifecycle Logging Activity that inherits from the activity class, and then you can override the various lifecycle hook methods to print out to the logger that they're being called at different points in time. And if you build an Android application using this by inheriting from lifecycle logging activity instead of the normal activity, you can see very easily by looking in your development environment's log capability when the different transitions are occurring between the different lifecycle states. Note also the use of inversion of control in the activity framework. You're not calling these methods directly. They're being dispatched on your behalf by the Android runtime system. In particular, this is using something called the Activity Manager service behind the scenes to do this work. Let's now talk a bit about the Android service. This is a bit more relevant to the context of networked and concurrent apps. A service is an app component that runs in the background, and it performs long-running operations, and it does not provide direct access to the user interface. So you would typically use a service for certain long-running things. You might handle network transactions in a service, you might play music, you might interact with a content provider that stores data persistently in an SQLite database, you might run various periodic tasks and so on in a service. As you've seen, there's a running example we've used throughout the class of an application I've developed for some of my courses where we download images and use a service to help to decouple that downloading from the activity where the user interface interactions take place. An application component can start a service. For example, an activity can start a service, and that service will continue to run even if the user switches to another application or another activity. Components can also bind to services and interact with them to perform various kinds of local or remote inter-process communication. And you can see this URL for lots more information about services. So how do you implement a service? Well, implementing a service in Android is very similar to implementing an activity. You inherit from service, and you override a number of hook methods. Depending on the kind of service that you're defining, you'll override different methods. And then you would go ahead and add this service implementation to your Android manifest file so it's known to the system and to Package Manager. Android communicates state changes to a service by invoking the lifecycle hook methods as callbacks, and we'll talk more about that in a second. But before we do that, a quick recap of commonality and variability. The service class component provides a common interface for performing these long-running operations that don't need to directly interact with the user. Subclasses can then inherit from the service class and fill in what needs to happen for different kinds of services to initialize different services, started services, bound services, and so on. And we'll take a quick look at that on the next couple slides. Here's a quick overview of the service lifecycle hook methods. There's a method called onCreate, much like there is with an activity, which is called when a service process is created by whatever means it's created. There's a couple of different ways you can create a service. One is using the command processor pattern by invoking the start service method, which causes the onStart hook method to get called back in the service. This is typically used when you launch services and want to be able to have them do something on your behalf, but not keep them around for a long period of time. There's also another approach for so-called bound services, and this implements more of the broker-like pattern that we've talked about before. In this particular way of doing things, you call bind service, which starts a service up, and then you can go ahead and interact with it. When you do this, the onBind call is automatically invoked, which can be used to pass back a binder object back to the client. And when things get shut down at some point, unbound will be called automatically by the Android runtime. And then, as with activity, there's an onDestroy hook method that's also called back when a service is going to go away, either voluntarily or involuntarily. Note that services don't automatically run in separate processes or threads. If you want it to run in a separate process, you can do some steps in the manifest file that we'll look at in a second to designate that a service runs in a separate process. If you want it to run in a separate thread, then you'll have to use some of the concurrency mechanisms available in Android, or use something called the intent service, which uses a command processor-like model to run the requests that come in separate threads. Here's a very quick example illustrating a threaded download service example. We can have a situation where we inherit from service and create a threaded download service, and then its onStart command method could take a look at the parameters that are passed along with the intent as extras, and then use them to download the designated content from a remote server using whatever is the indicated or desired concurrency model. This illustration here at the very bottom of this slide shows how you can make a service run in its own process by changing the declaration in the Android manifest file. Note again the inversion of control that's taking place here. You don't call onStart command. You don't call onBind or onUnbind and so on. Those calls are made on your behalf by the Android runtime. So to wrap up this part of the module, the Android framework components like activities and services support inversion of control. That's one of the key characteristics, key defining characteristics of a framework. And they also embody many commonalities and variabilities of mobile application development, which is one of the things that makes them so powerful. There are many, many patterns used in Android. In earlier parts of this section, we've discussed a number of patterns that occur in the Android infrastructure. Things like the broker pattern, or the proxy pattern, or the command processor pattern, or the observer pattern, and so on. There are lots of other patterns that are being used there as well. It's also interesting to note that there are many patterns for interacting with users at the application level. There's a book on Android design patterns for user interfaces. There's websites and so on. So if you're interested in patterns for Android, there are many different places you can go to learn more about how to apply these techniques to your systems effectively.